So, hello everyone. So, today we are going to do the remaining questions of the chapter called Dual Nature of Matter and Radiation. So, today, first of all, you can see these questions. These questions are of 2 marks. They are of 2 marks and they have been asked in the previous year CBSE exams as well. So, let us start the first question. So the first question says, explain the term stopping potential. Okay, explain the term stopping potential and threshold frequency. Pretty easy, yes? So, I have written the definitions in the previous notes of my previous lectures. You can watch them as well. They are present in my own channel. Okay, my name is Kumar Lechu and their name is Hello everyone, my name is Kugal Chung and I welcome you all to my YouTube channel. So, in the previous lecture, we did some few questions of this chapter called Dual Nature of Matter and Radiation. Okay, so we are going to continue that. So here I have some few questions. They are of 2 marks and previous year CBSE questions as well. So let us start the first question. First question says, explain the term stopping potential and threshold frequency. We have done this question in the previous question. We have done the definitions and explanation of these two terms in the previous lectures. If you want to watch them, they are present in my own channel. Okay, the name of my channel is Kumolekcho. You can have a visit and check the terms there. So so stopping potential the stop so stopping potential is the minimum negative potential applied at the collector side. Okay, collector side of the photoelectric setup for which photoelectric effect is stopped, or you can say emission of electron is ceased. The threshold frequency we have done this surface on electron in a radiation pole electron so threshold frequency is the minimum frequency below which photoelectric effect is not seen. Hey, new definition definition threshold frequency is the minimum frequency of the incident radiation that is required to overcome the binding of electrons, or you can say to overcome the attractiveness of electrons so that they become free. But this here okay? Threshold 딱 따라나 그냥 electron 되기만 해. 대체도 그냥 extra kinetic energy 고래. 이 also 비교를 장사들로. If you haven't watched the videos, I highly recommend you to watch the early videos. Okay, earlier videos to have a clear concept. Now, the next one, okay, 2 marks question there, 1 marks for each definition. The question number 2. Using Einstein's photoelectric equation, show how the cutoff voltage and threshold frequency for the given photosensitive material can be determined with the help of a suitable plot or graph. So, how the cutoff voltage and threshold frequency for the given photosensitive material can be determined with the help of a suitable graph. So, take the answer. Okay, this was asked in CBSE 2012 exam. So, cutoff voltage and threshold frequencies for the given photosensitive material determined with the help of a plot or graph. Okay, using Einstein's photoelectric equation so teacher photoelectric equation in the current we know now what we know that kinetic energy max of the emitted photoelectrons is equal to energy of the incident radiation minus work function, and this is simply called Einstein's photoelectric equation. Okay, so this is simply called Einstein's photoelectric equation. Now, guys, here we have to find cutoff voltage, that is called stopping potential, and threshold frequency. So kinetic energy max can be written as EBS, charge of electron into stopping potential, and energy can be written as h nu, okay, using Planck's equation, and phi naught can be written as h nu naught, where nu naught is your threshold frequency, or you can write it as EBS is equal to h combination nu minus nu naught. देखो 딱 그냥 가르쳐야 돼. Vs 이렇게 or you can write Vs is equal to h. Okay, so 그냥 이렇게 h e nu naught minus h nu naught minus e. 이 direct मान लेना ठीक है So 먼저 뭐야 equation 되대. Stopping potential is equal to h nu upon e minus h nu naught upon e. Now we know that their relationship is a straight line. So since their relationship is a straight line, we can apply y is equal to mx plus c. That is the equation of straight line. The equation number 1, equation number 2. Comparing both equations, what you get is the slope value. Okay, slope value m. So compared to now, slope differences. Vs is equivalent to y, and nu is equivalent to x. So can the slope is h upon e as well. So question number for the sensitive material, how cutoff voltage and threshold frequency can be determined. So slope h upon e na any constant graph this distribution. This graph threshold stopping potential the potential frequency graph the 100 where this is your minus phi naught upon e, that is your y-intercept. Y-intercept, that is phi naught upon e. 딱 그냥 가르쳐야 돼. 대단히 the graph 되니 그냥 slope लगी रहता है, that is tan theta. ग्राफ देने क्या slope चिग रही तो tan theta दी दिख रहा है. ग्राफ ने क्या slope चिग रही है. The graph ni क्या slope लगी तो दी tan theta है. Now tan theta दी क्या घट है Vs upon u. Vs upon u, or you can say dvs or dnu, change of dvs upon dnu. The slope by equation we got the value of slope as h upon e, but through the graph we got dvs upon nu. The let do. Therefore, क्या vs की value दिखाया सो vs upon nu will be equal to h upon e. That's what. Now, क्या Vs की value क्या h upon e into nu. This is the value of stopping potential. Okay. So क्या stopping potential की value दी okay through the graph. यहाँ की चिक की threshold frequency की value छे ना. Threshold frequency value है ना work function is work intercept is intercept कर सकते phi naught upon e ना phi naught upon e ना h nu naught upon e okay minus h nu naught upon e so minus h nu naught upon e the formula लिखा ना y intercept is also y intercept is now y intercept is as well. So through the y intercept what you can do is for the given particular material can be determined with the help of a suitable plot or graph. Okay, so dvs upon d naught. Okay, so this is the Question number the threshold frequency the formula ni determine chegi mada. So kya khal hai plot ki graph the plot chidi the point the new not real any determination that you. Okay. So this new not mada na kya na photoelectric effect tungi male. So what you have to do first write this equation theta the graph plot chi and b is given. Say new not kya the formula tunse hai male just show it in the graph as the point. The point. Okay, so this is for 2 marks. So you don't need to write much English. Mathematics Chiputisha. Formula the chief answer for the equation. The graph decision and the value decision. Okay. It is a bit. Just pause the video and write it. That's all. Okay, moving on to the next question. CBC 2001. For the photosensitive surface, threshold wavelength is lambda naught. Does photo emission occur if the value of lambda naught of the incident radiation is more than lambda naught? Okay, so value of lambda is more than lambda naught or less than lambda naught. So, can you solution criteria? Solution nana. Solution nana. Part 1 nana. When lambda is more than lambda naught. Okay. So generally, that is kinetic energy. Einstein formula equation here. Kinetic energy max is equal to lambda की formula करेंगे anything here. Then to your lambda की formula लगे से photoelectric Einstein formula equation थी ना ये kinetic energy max is equal to hc 1 upon lambda minus 1 upon lambda naught. Lambda naught is your threshold wavelength. Now threshold wavelength भी किसी LD lambda not है मान है ना D मान D nuance so overall D value defines nuance so when this happens when lambda is greater than lambda naught kinetic energy max comes out to be negative. Okay, case new another when lambda is less than lambda naught. When lambda is less than lambda naught, kinetic energy comes out to be positive. Thus, this also some important. In case can kinetic energy be negative? Can kinetic energy be positive? So, my friends, in case of case 1, okay, in case 1, photoelectric emission will not happen, but in case of second case, it will happen. Kinetic energy can never be negative, it can only have a positive value. So, example, I can by Einstein's electric photoelectric equation, write the formula and write the different case and negative case or positive case. So, this in Chungumade, write your own English words. Now, this question number 4. Question number 4 plot a graph showing variation of de Broglie wavelength lambda versus 1 by root v, where v is the potential, accelerating potential for two particles A and B. Okay, and current given into mass m1 the m2 the mama the. So, take a solution to this now. Okay. Tata, dinala, you see, we know that de Broglie wavelength in terms of potential, de Broglie wavelength lambda the, you see potential in terms of h upon under root 2m qv. Lambda is equal to h upon under root 2m qv. Therefore, lambda is inversely proportional to root v. Okay. Tata, here we are not showing drawing the graph between lambda and v. V the lambda per the graph should be directly 1 by root v equals to 0. So we have to consider 1 by root v as a y, or you can say anything, any variable. So root v is inversely proportional to lambda, but 1 by root v is directly proportional to lambda. So, then he said this way now, you will get a straight graph with positive slope rather than negative slope. Okay, positive graph ची बात बोले. Suppose देखिए कि lambda image है, दी वाला 1 by root v हो जाए. Okay, this is your origin. देखिए कि origin है. ता देने की graphs जो है, इन आता देना है case 2. You have to make two graphs, a छेदु ने v छेदु. Particle नी छेदु. Now particle A की mass थी m1 दे नी 2 की m2 से, and m1 is greater than m. ता यहाँ compensate. So the लेला बोले देला root v ना depend छेके दो m ना depend छेके दो. तो lambda is inversely proportional to root m है हमारे. तो lambda is inversely proportional to root m. So नेरे छाती क्या की कल आया दे mass की न्यू आया ना. Okay, whichsoever has a lesser mass will have more wavelength. So mass the new m1 m2 the new m2 has lesser mass. Now m2 the less mass new na lambda की value थी थोड़ा है. So क्या कर रहा है for m2 the slope is higher and for m1 the slope is lower. Considering due to this reason. So क्या की ग्राफ नहीं सोएगा. ठीक एंड स्ट्रेट. Okay, तो दीनी ने कंडी शेगरी. दी देखिए हम ये. This is your m2 and this is your m1. Okay, this is your b and the lower one is your a. Yeah. दी की theta दी चुमाले दी की theta दी चाले. So you will get a graph something like this. Okay, 2 marks the question there. So can you please this dish it in but main answer then formula the t and make the graph. Okay, sure. Okay, so last question. A proton and an alpha particle are accelerating through a same potential. Which one of the two has? So solution number. So you got the potential same way. Okay, potential same enough. V1 is equal to V2 is equal to V. So which one of the following has a greater value of d Broglie wavelength associated with it? Okay, proton the alpha particle. So potential becomes a lambda is equal to h upon under root 2m qv. Is the thing what is it? So formula is very important. The this is the which one has greater d Broglie wavelength. So V constant ले दो, Q नहीं constant ये बचे, charge constant. So V constant there, so charge the mass the potential पे दो, so the mass है. So proton की charge थी QP, proton की charge थी QP दे, okay, and proton की charge थी QP दे, and alpha particle की charge थी खाले. 2 times QP. मारे doubly charge helium particle मारे. So क्या कि QP दी नो आने Q alpha दी मास है सो ले मारे. चिक पर चिक क्या mass of proton दी MP range है. इन proton दो खजे हो देखा alpha particle ना proton नी neutron द proton की mass चिक पर होती नी proton शी की mass द दो होते. Equivalent to 4 proton की mass. So mass यहाँ पर नो आतो proton. So the information you can send the share. This is the schedule. Therefore, lambda of क्या लिखा lambda of proton the greater than lambda of alpha particle छड़. इस हम क्या this dish है नो. कच्चे because छामा वो लगवा inversely proportional. Lambda is inversely proportional to mass and charge. So whichsoever particle has a lesser mass and charge will have more wavelength. So proton la mass है. Now part 2. So शेरा 2 was like I need 2 marks later. So 1 marks now there. So edit original okay. Just formula decision. Now to the less kinetic energy. So the kinetic energy no. Now kinetic energy charge की term में share करो kinetic energy in terms of charge is qb okay charge into potential now potential is constant j now kinetic energy is the amount k alpha kinetic energy of alpha particle is greater than kinetic energy of proton because charge of alpha particle is double to that of charge of proton. This is equation formula D okay, so we will do some next questions on your screen right now. So these are the last two questions of today's lecture. First one is an electron and a photon each have a wavelength 2 nanometer. Okay, so can be given Tisha given conclusion now lambda of electron is equal to lambda of proton equal to and lambda L lambda Tisha is equal to 2 nanometer. 2 nanometer means 2 into 10 to the power minus 9 meter. Now, find the momenta. Momenta. Once again, momenta their momenta means lambda check is in a deal. So lambda dua. So part 1 momenta so lambda is equal to h upon 2. Therefore, momenta is equal to h upon lambda. Further equal to 6.63 into 10 to the power minus 34 upon lambda. Now lambda is 2 into 10 to the power minus 19. Now 2 the 2 they cancel on 3.32 something okay approximately. So momenta given to us 3.3 into minus yatasha. So 10 की power minus 25. Now momenta की ऐसा unit खड़े momenta देना खड़े जितना की momenta means mass into velocity. So kilogram meter per second. Okay. SI unit is very important. जैसे क्या है कि लेट डिटेल है SI में ना आगे छावा दे so SI unit क्या है SI unit का क्या नाम की फॉर्मूला दे क्या तो है दे mass to velocity. Now second part ना the energy of a photon and okay so energy is ये वाला energy of photon. Now photon की energy खड़े h nu h nu further equal to hc by lambda. That is your Planck's equation. Now lambda की formula that's क्या लिखा so क्या लिखा है hc by lambda से 6.63. Okay यहाँ में ना क्या ना है shortcut चिकला भी ना लौट हम भाई ना shortcut दिला भी क्या कि लेग में अच्छे इंशाल्लाह से ये तो E is equal to hc सब ये खाई चले 1240 nanometer electron volt measure down upon wall again lambda दिखाई ना bonus nanometer so given to so 2 nanometer cancel 2 the cancel down energy खाई ना दे 2 की cancel down ना 620 electron volt 620 electron volt is your answer. Question on the other hand, you can assign a so the end in that case, the question on SI at 3 620 into electron volt. 1 electron volt is equal to 1.6 into 10 to the power minus 19 into Nasha. Answer like Joule answer. Okay, simple. Now third part now kinetic energy of electron की kinetic energy थे so क्या कि kinetic energy नाम की फॉर्मूला दिखा रहा है kinetic energy is equal to half mv square है okay दीनी जो बोल रहे तो last question है kinetic energy is equal to half mv square तो हिना यार मुझे कि velocity given है no velocity में तो क्या कि खर्च किया है ना Momenta given it. So momenta terms na ate term is na multiplying numerator as well as denominator by m. Consider because side like can see mass ki divide ta numerator the denominator ka dan chipala one chaso. Ina yang ala form shape the equation equal. Now mass into tana mv ki whole square that's what man. Now all of that is 2m mv khade momentum. So can we the kinetic energy the kinetic energy momentum ki square upon 2m. Go momentum is square upon 2m plus 2. Now, momentum देखा है 3.3 theta 2. So I will give you a homework and this is your homework. Formula दी विजुअल तानी क्या की kinetic energy की value लिखे दा and write the answer in the comment box. Okay? Last question. Last question of this lecture. Okay. So last question of this lecture, CBSE 2010 question. They are quite simple. Making you lecture na lagegi. Kya lati le get try to find the answer by yourself first. Okay, so we will do this. Lelo le kya alpha particle the proton ki ratio se la tu khai given the potential constant ji. Any color is na lambda particle alpha particle 1 proton 1 can we the ratio is equal to the video the question I will just write the answer here. H upon alpha की case में h upon 2m alpha q alpha v चाहिए into under root 2m p q p v upon h inverse they should. Now lambda alpha upon lambda p is equal to cancel v cancel cutting se na given the v is constant. Okay, now lambda alpha upon lambda p likha so under root 2 cancel तो गाना पता सो mp qp upon under root m alpha q alpha this also. Now lambda alpha upon lambda p is equal to mp qp langesha mp qp langesha. Now m alpha mass of alpha in terms of mv khare 4 times mp and q alpha in terms of qp khare 2 times qp cancel mp cancel. Now lambda alpha upon lambda p is equal to under root 1 by 8 that's what. Or you can say therefore lambda alpha upon lambda p is equal to 1 upon 2 root 2. Okay, so answer is this. So your answer will be 1 by 2 root 2. So that's all for today. I hope you all got the concept. You all have got the concepts quite clearly. So thank you for sharing. Okay, so if you like this video, please share it, like it, and please subscribe it, because my viewers, if you subscribe and like them, I get the motivation and you all get the notification of my videos. So with that, I will wrap up my video. So hope you all have enjoyed that. Keep studying hard and don't forget to study in a proper manner, okay, by giving equal time to all the subjects. Good luck.